I'm so sorry. In the group, I made mention of during our online classes, we'll try to cover our syllabus to see if we get to cover it. So basically, that's not the case. The main thing is that this online session is kind of like a bonus to you. Like, it might not be directly from your syllabus. It's just some outside syllabus stuffs that can help you in your embedded system development. So this class is just based on software development. We have treated software development in our last class, so but we didn't get to talk about something which is very important, one part topic like that. So let me open my slide. So we talked about software development, and here what we are going to talk about is like the continuation of that software development, which is not part of our syllabus. It's just like a bonus for you to know software development in broad. Like when I say software development, whenever we say software development here, it's like we are referring it to the embedded system, software development for embedded system, because that is what we are doing. Like, let me try and open my slide. So I sent a PDF on group. I believe maybe some of you might. Hello.
Yes, fine.
Okay. Sorry, there is background noise. Alright, thank you. So I've sent a PDF in the group. Let me share my screen. I have a lot of tabs here, so it's kind of. Let me share my share my entire screen too. Okay, can you see me? Can you see my screen? All right. So let's get started with the PDF. Sorry. So as you see, it's about millis and delay function. These functions are very essential, but we can't just jump in and start talking about milli function or delay function just like that. We have to, yeah, it has some prerequisites, like we have to understand 2 to 3 things before going into it. So this is our agenda. We are going to do the recap from our last class. Majority were not there, but just the main point, not in details. Then we'll get to the millis function, and then I will give you some recommendations, in your development. So the recap is basically just the PDF that I share. It's just talking about what software development. We all know what software development is. Like, why do we need the software itself? What roles does it play? We all know that we can't do without what do you call it? We can't do it with our embedded system without software, right? Because software and hardware they are all dependent. They depend on each other. So we really need software to manage and control our hardware devices, right? Our hardware units. Though there has to be some hardware parts, that they are kind of dependent, like more especially the integrated IC, a circuit made from integrated IC. It can operate right without even software in it, without even code or OS in it. Why? That is not true, right? Because the integrated circuit has been programmed. The what do you call it? The arrangements of what transistors and diodes to make the circuit perform a specific type is what is you are programming your circuit. It's not programming just doesn't mean coding. Okay, you can program your circuit with what, with combination of logic gates, making logic gates perform also operation for you with the help of diodes, transistors, and stuff. So that is also programming your software. So it is not necessary when you say program your device. It is not necessary that it means what, it means that you really need to write code and upload it to your device. No, no, no. Like you can do it like manually, but that one is really time consuming, right? Thanks to the microcontroller, we can what, we can be adjusting the logic gates and what the operations there by just what, uploading a code. So that is just it. In software development, what will we do is just what, developing the life of the what, the life of the, what do you call it, the system itself, the brain, the everything. So what we did was just that we made use of some functions which I believe you guys are already familiar with it, which is the analog write function and the what, and the random function. So we also apply loops. So sorry, as you can see here, after discussing about software development, we just what head to what, we head to what, loops, functions. Then we start applying this loop and functions in what, in our projects. So this project, red, green, blue LED stuff, we have applied what, the loop inside, where the loop we applied for loop. You know, we have types of loop, the for loop and while loop. So we apply for loop in this RGB. What was the essence of the for loop? The essence of the for loop is what, is for it to be what, um, uh, what do you call it? Gradually changing the color of our LED from maybe red to green, because automatically if we say digital high, digital low, it instantly will take effect. But when we say what, we write a for loop that will be gradually owning it on and turning it off, that will be much what, that will be much more smooth, much more attractive. It depends on the application, right? It depends on why you need it. Let's say you are trying to design a studio, something like you will need this type of application, right? So, and we also did one thing. We made use of the random function. The random function, what does it do? It just made a random value for you from a range. You just call the function write random and what, write the value, which is in our case we need 255. How do we need 255? How do we know that we need 255 in the first place? Because the analog write function, this is very important, something that someone needs to know as long as you are into embedded system. You know, our embedded system are based on bits, right? Even our computer, 32 bits is 4 bit and stuff. So the, what do you call it? The Arduino is 8 bits system. The microcontroller is 8 bit based. So for you to get the total number of bits that microcontroller can output, you are going to use this formula. Let me be zooming things on. You are going to use this formula, which is what, 2 to the power of n minus 1, where n is what, where n is your what, is your number of bits. So it's really important. Just 2 power, what do you call it, our number of bits is what, it's 2 power 8 minus 1, it will give you automatically 255. So that is why we get 255. It's going to give you 256, then you do minus 1, this minus 1, that will give you the maximum number. That is how we get this 255. And we store it in a variable, that the range, and then what, we analog write that value to what, to the pin of our LED, and then you will see the LED with their for loops and stuff. It will be displaying some colors, like attractive colors. Then we head to functions. Functions, they are very simple and straightforward. Functions are just what, some block of code what, that you will be using them in your code, but you don't need to be writing them each whenever you want to use them, right? So you just write them once you need them, then you call them, and they will be what, executed automatically by passing your parameter. So I'm trying to make this fast, like, you know, it's self-explanatory, some of it, and I know some of us here maybe might have know this thing already. So we just what, made a function that adds two number, which we need to specify what the type of function, which is int. That means the function is going to handle what, integer values and stuff. So let's just fast forward this thing. We made use of what, ultrasonic sensor to what, to distance. Then we apply what? Then we apply functions. That function that we learn here, it is what we apply here to help us what? Do this calculation. We can do this calculation in our block line of code, but in our code normal void loop. But what? To make it more efficient, we find a space somewhere. We create a function separately that does this calculation, though it's an assignment actually, because the one I gave in class, it was not on this one. I say that people should go and do this one as an assignment. Just make a function that will what? That will correct the that will pass the parameter. Which parameter will be passed in time, right? Will pass the parameter time, and then what? There will be formula in the function that will what? Calculate the distance with the help of that time, because your velocity is what? Constant. And then we made use of servo. We applied loop also to make the servo what? Once you write your servo, once you call it a function, write servo.write. That is what you are trying to change the angle of the servo, and you ask the servo to move towards what? Angle 180. So it will automatically instantly what? At a high speed what? Go to that 180. So what if you want a smooth movement, a smooth from A to B, maybe from 0 to 180, with the help of for loop or while loop, you can achieve that what? Smooth movement by what? By assigning it to be moving it once in a time. Then what? That means you will have what? 180 iterations. Iterations means what? Repetition. Like after it has moved at 1, it will move to next plus 1 plus 1 plus 1 plus 1 up to what? Up to that 180. So that is the iteration. While adding what? Because if you didn't specify your delay function there, it will do the same thing as moving as fast. But if you add your delay for each iteration, let it wait for what? Like 50 milliseconds. Then you will see your servo moving very, very smooth. So that is our recap. Sorry, it's kind of take our time. I really emphasize on the recap because I know majority were not able to attend due to some issues. Let me get to my slide. So you see, the next thing we have here is what? The software development, which I finished explaining everything there, like almost everything there. So just developing software and stuff for our program. The IDE, all of us here now, we are gurus now utilizing our IDE, right? That is our integrated development environment. The one we used to use to program our code. At the top, at the upper top, we have what? We have the place where we'll do what? Call our libraries or include our libraries or what? Or set in or do some certain initializations in our what? Setup. What do you call it? In our setup loop. Setup loop. We can do what? We can initialize our maybe some devices or some variables that needs to be executed only once, right? Then our loop down, we can do what? On our void loop, we can execute our code that we need it to be repeating over time. In that class, I don't want to talk about it. In that class, okay, I don't think I taught them. I didn't taught them, but I wanted to tell them about, but there was no time there. I wanted to tell them about what if you want to execute code once in that void loop. That void loop is executing code continuously, right? But there are times that we'll need a code to be executed once in that place. So we can achieve that with the help of what? Either if statement or what? Or for loop or while loop. They are very essential. Then we have what? Sorry, this thing is very fast. Then we have what? Functions. The functions is what? Is the creating your own function, which is like the one that adds two number. Then I want to what do you call it? Give you additional function that will help you in your development. I think it's here. Let me try to make it bigger. Okay, it's not getting bigger, right? Then give me a break. Okay, let me see now. Yeah, so this is it. This is a void loop. The function I want to give you is mapping function and the constraint function. What is the meaning of all these functions? The mapping function and the constraint function. They are all very essential. So let me just explain the code very quick. The purpose of the function is just to on our, what do you call, the RGB. You know the RGB have three legs: the red, the green, the blue. Okay, four legs, and the ground. So instead of doing digital write to each thing, you can do analog write. And the purpose of that analog write is that the advantage of that analog write, the main difference between that analog write and digital write is what is that in analog write you can output a range of value, like from 0 volt to 5 volt, like 2.5 volt, 3.5 volt, 4.5 volt. They are all range, right? But in the digital you can only output either 0 or 5, 0 or 1. That is what low or high, right? So that is the advantage of that, what do you call it, analog output. So what I did, basically I made a project just to collect value from 3 potentiometers, which is I made use of this analog reading. As the name applies to that, analog write range of values, writing analog range of values, that means what, outputting range of values. The same thing goes for what, analog read. Analog read also, you can what, made read of what, range of voltage. You can read a value that is what, between 0 to 5 volt. Either if the voltage is kind of low, maybe around 1.5, 2.5, you can make read from that, analog voltage there. But if you use digital read in the place where you used to use analog read, you know what will happen? It will just make, what do you call it, a conclusion. That what's that conclusion is that any voltage from 0 to 2.5 will be count as what, will be count as 0. Any voltage 2.5 to what, to 5 voltage, it will be count as what, high, which is 1. So if you do analog, digital read, why you need to do analog read, that is what the digital read will be doing. It will just be outputting, reading you 0 or 1, depending on the what range of voltage. So once you do read that, your what, your value here, which is potentiometer A, and we are storing it in a variable A, what will happen? It will study that, voltage. 0 means 0, 5 voltage means 1023. That's the range of voltage. 5 voltage means 1023, 0 voltage means 0 voltage. If you divide it by 2, it 2.5 voltage, it will give you that number that you divide by 2, which is around 512 or something. So that's it. That is how you do the analog grid. So once you do that analog grid, I believe we all know how the potentiometer works, right? You can adjust voltage from what, 0 to 1, like 0 to 5 voltage. So I will be adjusting my potentiometer, collecting that value and storing it in what, in the potentiometer. What shall I do next? I want to be taking that voltage as reference that I measure from the potentiometer to what, to make impact at what, at the output of my um, LED, that red, green, blue LED. So how can I do that? Is by what? By using another function which is called what, the mapping function. What does that mapping function say, used to be? Because we say that our Arduino can only output what, 255, and the voltage we are taking, that's the maximum of the Arduino is what, 255, and what we are reading is what, 1023. So how can we take that 1023 and output it at what, uh, at that 255? In, I think in machine learning we used to call it scaling, right? Something scaling, or is it just scaling, something like that. So you need to match that scaling. You need to do that scaling between what, a different scale value with a different scale value. Okay, this one is maximum is 255, the other one maximum is what, 1023. So we need to do that scaling to make them what, balance. Like 1023 should be equivalent to 255, 0 should be equivalent to 0, 512 should be equivalent to what, divide your 255 by 2, then you see it will be balancing. So that is the importance of this map function. You will use this map function, call that your variable that you have stored your 1023, put it here, do a comma. Let me just, it's the same thing as what, as your, as the new variable, your new variable that you want to store the work done inside, with what, with the map function, open your bracket with what? The existing variable. Don't mind my spelling, I'm just in hurry. The existing variable with what? With min and max of what? Of the range that you have taken of this variable. Specify the min and max of what? Of that variable, which is what? In here, I write what? 0 and what? 1 or 2, 3. Which is, when I come here, then I will specify my range, the range I now want it to be scaled at. I want it to be scaled at what? New min with what? New max, which this is the new value that I want it to be within the range, which is what in here is what? 0 to 255. So this is how we do it. So now this outcome will be stored in what? In this new variable. And this new variable now, instead of 0 to 1 or 2, it will be what? 0 to 255. Sorry, please, if I'm spending too much time, because I used to be confused. I don't know the things that people know already. I don't know the things that people don't know. So I used to be confused on what thing to spend much time on. So I don't think, if I'm thinking that I'm spending too much time on this, which maybe some of you might know, or it's not that, it's self-explanatory or something. So please, once you see I'm explaining too much time on something, you can just notify me, please, so that I will know, because it is kind of confusing. So that's it. Because I used to use this to others, it's very important to me. I don't know to others, but to me it's very important. So now, in some case, what if um we don't know that min and max of that variable we are measuring? Let me give you an example. This one is just a breadboard project, right? What if you are dealing with real life something? Okay, now you are dealing with real life application. This one is also real life, but let's say you are getting data from what? From you are getting data from what? From sensors. And sensors used to be what? Sensors used to be very confusing. Sometimes you don't know the range of data what that sensor may output. So it used to be very confusing, right? So how can you tackle that problem? Because now we know our range is from what? 0 to 2, to 1 or 2, 3 for our analog potentiometer. But what if that data is coming from a sensor? I know a sensor that we don't know the range it can output, because they used to output some signals, kind of confusing and stuff, with high value, low value and stuff. How can you tackle that problem? And you want to convert the range of the sensor value to what? To particular 0 to 255, or some range you want it to be. So how can you do that? So just to do that, let me now comment this ones and uncomment this ones. What is the purpose of what? Of this word constraint? So you can use this constraint to what? You can use this constraint to. Sorry, can you hear me?
Yes, yes, yes.
Okay. So you can use this constraint to what? To just let the function there, the constraint function, because if you write a code and you see that code colored red, what the function is doing is just that what? It's a what does that text mean is what? It's a function. The function that came with the Arduino, or maybe the one you imported or something. So this constraint function, what it is doing is what? It has some algorithms in it that just do the word calculation for you, and you just need to pass only your words, the data you have read from your sensor, which is my A. In my case, this is it. A, I've stored this value I've read. Let's assume this is not potentiometer, it's a different sensor. I've read my value and store it in A. So then I pass this A and telling it this is my target value. Okay, then I just need to specify what it doesn't have this part. It doesn't have this existing. No, sorry, it has this existing, which is what? Existing variable, which is what? Which is your A. Then you then need to specify the mean and the max of the value you are measuring, because what, you don't know that value, you don't know it, right? You don't know it, you are just measuring it. So the thing is that you only need to specify what the value you want it to be, which is your 0 to 255. So now the Arduino will assume what you don't know the range of the value you are taking, so it will calculate and see, okay, this is the higher value I'm getting from the sensor. I didn't get any value that is higher than this. Okay, this is the minimum value that I'm getting from the sensor. I didn't get any value minimum than this. Okay, I will assume this my min, this my max. Okay, now I will take it as like that. Then what, I will convert it in the range of, I will scale it in the range of what the user's requirement, the user need, which is in our case is what, 0 to 255. So that's it. Then I was doing what, I was doing analog writes. That is what, I'm taking the output and outputting it at what, at the at my LED, and what, putting a delay function which is just 50 and stuff like that. So I'm sorry, just hang in there. So our target port is what, is just A0, A1, and what, and A2. I'm sorry, I really, the thing was this, I wanted to use Tinkercad. It's we have Tinkercad. It's a platform, online platform that you can go in there, do your circuit design, a 3D circuit design, and it is very friendly. So my own was kind of misbehaving. So I wanted to design all the circuit diagram of all these codes and send it to you. So it's kind of misbehaving. Maybe I will try it later. If it works, then maybe I will share it in the group. But it's really important here, not just in the group. So let me just try uploading my code and see. Nobody ever was declared. Okay, the what do you call it? The example I gave here. Okay, let me open my serial monitor. I made use of serial monitor, right? Okay, I commented it. Okay, it's very fast. Not delay. Let me be adjusting them. Right now they are all what, at 000, at 255, which is our maximum. If I'm adjusting it, you can see what it is changing. Don't mind this, is just the connection.
Can you increase
Please, you said?
Can you increase the, can you zoom in?
Can I?
Like,
Can I what? Zoom it. Okay, just like before. Where is my magnifier? Okay, I think please, if you have any questions so far, you can ask before I finish up with the circuit. It's just misbehaving.
okay. About that constraint, I'm still trying to get what's actually going on. Like, what if the sensor is misbehaving and then shooting, and like maybe shooting going very low or shooting? Does it automatically mark?
Okay, very high.
Yes.
Yeah, the Arduino actually, like, I haven't, what do you call it? I haven't go into the function and see how the algorithm works. But basically, what it should be doing is just it will try to provide you with high accuracy something, because it cannot be 100% perfect, because the data is analog. It can shoot maybe higher and maybe shoot very low, and then it's, the range can be changing with time. So I don't know how actually the algorithm works. So, and had it been, it's now they have developed it with machine
Come
learning
on.
and stuff there. Okay, sorry, I didn't hear you.
No, don't worry, don't worry. I can hear you. I can hear you.
Okay, so that is how it works actually. It will just try to give you as a higher accuracy as possible for your range. But my computer seems to be out like this, like playing some game or something. So now let's see the output.
It's like the slide. I can't see the slide.
You can't.
I mean the slide. Like the slide disappears.
Disappears.
Maybe it's only for me, but I don't know. I can't see the slide.
Like you can't see my screen.
Yes, I think it's stopped sharing. It's only me or if other person is affected.
Please, is there any other person that is not seeing my screen?
Just up and down now.
Hello, can everyone here see my screen? Seems like they can see my screen since they didn't reply.
That's seeing it.
You are seeing it?
Yes, we are seeing it.
Okay. Can you still see it now, someone?
No, I can't see the screen.
Let me stop it then. Because I have a secondary device with me. My secondary device also cannot see the screen.
Okay. Yes, it has come back now.
Same thing. Let me on. The purpose of my secondary screen is for the camera. Oh my god, it's so low quality.
Yeah, but you can see it.
Oh my god. I don't think anyone can understand something from this. This is my 3 potentiometers. This one. This is my, what do you call it? The RGB body. You can see, you see the color. It's getting changing as I turn on as I twist my the knob of what my potentiometer. So, yeah. So you see that is it for this one. Though the circuit is still not functional, as you can see the place is too cluttered with wires, so the circuit is giving me a headache right now. So instead of wasting too much time, since you have grabbed the concept, that is what really matters. Because now if I'm continue to adjusting this thing, it can take us time. You see it's cluttered with wires, so many sensors, because I was thinking I'm going to explain too much on some few devices here. So let me turn off my camera. Alright, let's get back to our slide. Alright, let's not waste too much time. So we have talked about functions, right? The constraint and the map. The mapping is just once you know the variable, the number you are, once you know the value you are measuring. While the constraint you don't know the value you are measuring, but you want to map it at what? At a certain scale. So the next thing is the millis and the what? The delay. So you see, the first thing I should be discussing about it is the number range, which I finished discussing about it. The next thing is the delay function. So let me get back to my code, or let me talk a bit. So delay, you already know what delay is. We used to call delay function once we need to wait for a certain time before executing what our next line of code. So that is why we call delay. And the default unit of the delay is what? Milli, because it counts in what? It's seconds, right? So but it counts in what? Milliseconds. So that is a default unit of the delay. But we used to have some other range of units, like delay microseconds. I don't think maybe if there is any, but these are the two ones that I know they are very popular, which is the delay, normal delay, which acts in milliseconds. And once you want to delay little bit, it's once you want to delay more longer, more shorter, that is when you call the what? Delay a millisecond, a microsecond. That means that what? It is a very short delay. That we used to use that in once we want to use the pulse. We need the pulse from that microsecond. For example, our ultrasonic sensor. Our ultrasonic sensor is the one that, okay, instead using my camera is better than I use what I use the web. So you all know what the what ultrasonic what how the ultrasonic sensor is to what looks like. So it's just this is it. It's just something like this that have the word VCC, the trigger, the echo, and the word the ground pin. So that trigger, we used to trick the signal using that delay microsecond. Because if you check our code, the code I sent in the group, we used to use what? We used to use that delay microsecond to just shoot that signal for just 10 microseconds. It's a very small pulse that can be what? That can be that something small can be what? Can be up it's obstacle, right? Because if the signal is good, sometimes we used to have some very slow signal that was used to penetrate through objects, but it depends on the mechanism being used or the code being used or the type of waveform, because you have so many types of waveform: the square, the sawtooth, the sine wave, and sinusoidal. That's the sinusoidal and stuff. So this is it. Let me. Where is my magnifier? So this is our delay microsecond. You see, this trig means that the variable storing our trigger pin number. So we set it high and we only delay at microsecond, very short pulse of 10 microseconds. Then we watch, turn it off. Then that pulse will travel what along the airspace towards until it reach an obstacle. That is this thing. It will travel what along the airspace without hitting any obstacle until it reach an obstacle. Once it's meets with that obstacle, it will reflect and come back to what the echo. We have this one is the trigger, the one emitting the signal, and this one is the echo. So what happens if it doesn't reach any obstacle for certain length? Let's say for kilometers. What do you think will happen without reaching, let's say, on open road? We just trigger that signal at an open road without any obstacle. What will happen is that the signal has its own limit. It can reach its limit. The moment it reaches that limit, I think for this prototype, this one that we used to prototype mini project, because for kind of practical and stuff, it's a small sensor. So it can, I think, only reach up to maximum of 200 centimeter. You see, very small, right? 2 meters, I think. But if you want to use it for higher applications, because I once developed this type of project for surveyors, these surveyors that used to survey land and stuff, so they used to make use of it towards measure a particular distance. But what you need to get a higher ultrasonic sensor that can reach up to what some meters, that can be applied in some applications, because even the higher ones cannot cover very high range, because you see it's just pulse and stuff. So let's get back to it. The next thing is what is our milli function. What is our this milli that we've been talking about and comparing it with our delay function? So I need to be very fast because I see we have almost reached an hour. So our milli function is what, let me make it big. This millis that we've been hearing about is a function. What does that function do? We say that our delay function used to make the system wait until what? Until that second has been fulfilled, until what? Until we execute the next line of code. So the thing of this millisecond is that once you call that milli function, immediately once you on your Arduino, once it starts running, or once you reset it, as long as it is booting already, then you press the reset button, then it resets. At that time, it will start counting what? It will start counting the number of times, the number of seconds, milliseconds. That is what it is, right? A milli, then s, the milliseconds. It will start counting in milliseconds until what? Until I think the maximum it can count is about maybe a day or something. I can't remember actually. You can check the reference. You can check the reference somewhere, but it used to count much. So it will just be counting the number of seconds the Arduino has been spent on since the time you on it. Okay, it's just like once you on your mobile phone, maybe in some your database, you know, your phone used to calculate, right? Used to say, that is why you will see the graphical representation once you go to, I think, battery consumption, right? So that battery consumption, how does it act? At the moment you on your phone, that battery consumption will what? It has some certain functions that will be called what? What are the purpose of that functions? Is to be counting on what the amount of time the phone has been spent since the time you have on it. Then what? Be using that time and be calculating what? Power consumption. That means what? The apps you have opened. Okay, I've opened this app. Okay, your phone will know with the help of certain algorithms. It will know that okay, you have opened this file, this app, and this app has consumed certain percentage of your power for such duration of time. You see how important this thing can be, right? You will be tracking your activity, your phone activity. Okay, since at the time I on my phone, I have entered this, entered that. So even if someone collected your phone, made use of your phone, you know, we used to have what do you call it? Sorry, I can't remember. And it's the place where you used to do some minimize and see your recent apps. Okay, the recent tabs, yeah, the recent tabs. The place where you see the recent apps you have opened. So even if that person uses your phone and remove them from the recent tabs without you noticing, you can go to that what? That battery of consumption something and what? See the list of apps that have been used, because they what? Each app used to consume battery, and you will see that amount. So that is the purpose of this melee function. It used to count the time. It depends on where you want to use it. It depends on where it depends on you, because you can't just call a function without just now, because you know milli function, you just can't just call milli function just like that and leave it just to add weight to your coding or stuff, or you want to see too many lines of code, just call milli function and leave it. No, it depends on where you want to use it actually. So it has pros and cons. So the pros of the delay is what is you can make your system what you can make your system pause automatically for that particular time, and what and then execute the next line of code. At the same time, it is your con, because what it is an disadvantage, because there are some certain times that you don't want the system automatically to be paused, because when I say the system is paused, that means that the whole system, no any activity will be carried on. The system will be paused automatically. It doesn't matter how many sensors you have connected. It doesn't matter how many peripheral devices you have connected. It doesn't matter what task it was processing. It will just stop automatically until that time of delay has passed. Then it will keep on executing. As you can see, if you apply your embedded system in much higher application, that will be really what affecting your project. So the milli function, what you can use it. One of its advantage, you can use it as what as your delay function. Instead of using the delay function, you can be using the milli function to save time. What because that once you use that milli function in the right way, you don't even need a delay function. That is when you want to have what a high efficient embedded system. You can ignore the delay function, because sometimes in your project you don't need the delay function, because once you call the delay, it's not that you want to pause the system. It's just that you want to pause an LED alone, or you want to pause an potentiometer or something alone, not the whole system. But you don't have a choice, because it's the delay that they give you. You have to use it. So you can use that milli function in a way that you can make use of get rid of the delay function, and your system, your LED can be paused and on, pause and on, pause and on, without affecting what the rest of the activities of the microcontroller. I'm sorry I've speak much on this one. So let me get back to my previous slide where we did last class. I wrote something, which is this one here. Can you see it? The start time, the interval time, the current time, the condition, and then what the assignment. So the thing that happens is that you need these four things, these four steps, in order to get success in what and making. That is the disadvantage of the millisecond. It's not like a delay function. You cannot just call a delay function. I For a delay function, you can just call a delay function, right? And it will do the work for you. But if you want to use millisecond, it's not like a delay function. You have to follow a long road. You have to develop much line of code and much kind of thinking and stuff. Okay, I have to think, okay, at a certain time I want to do this, do that. So it's time consuming when programming, and it's you can easily make mistake, and that mistake can affect your whole project or your whole line of code, that it can make you spend times, hours debugging it. So that is the disadvantage of the millisecond. So you need to develop some line of code with the help of this start time, interval time, current time, then the condition, then the assignment. The way it works is that you need to set your active time. You need to set your start time. At what time do you want to start performing the tasks? The interval time, after so amount of second, after what so amount of second do you want to what to be doing, repeating the tasks? Maybe only an LED. You want to be on an LED maybe if after every 0.5 seconds, which is 500 milliseconds, right? So you need to specify that. You need to store that active time of your microcontroller at a variable called what the current time. Then you need to do what some perform arithmetic, which in order to check the condition, you will be checking the condition. What is the condition? That current time, the time of the microcontroller at that time, minus what your start time, the time you want to start. Is it greater than or less is it greater than or equals to what that interval, that your interval that you want? Then if it is yes, okay, the microcontroller, okay, now is the time for me to what to perform this task. Then you will open your brackets, you know, the bracket that you use to contain the block of your code. Then what then you will The first line of your code will be what you will start. You will make the start what the start variable, which is the start time, to be equals to what, to the current time. I'm so sorry, I'm taking too much time. Let me just do maybe even one, if it is just even one example, then I will maybe try to give you a reference to go and check some, because we can't cover everything here, because even now you see me with bunch of my devices here, the sensors, potentiometers, breadboards. I wanted to show you so many things, but I see the time is not going to allow us. Had it been this is a physical class, it will be better, because now we'll be consuming too much time. So that's software development for you. In the last class, I told some of my students that there was a time that what I wrote a line of I wrote a code in Python. It was earlier, since the time I was learning Python. I wrote a code in my Python. Um, that that Python is just a game. It that code, that project, it was just a game for me to play a game with the computer. So that code took me what, took me 300 and around 60 or 50 lines of code. So when I take it to my mentor, my mentor just laugh and say what, he can reduce that line of code to what, maybe a 25 line of code, or maybe 30 line of code. So you see, the purpose of this class is to teach you how to what, how to make your code very efficient. You cannot just code anyhow, because the system might run out of memory, or your system might kind of behave abnormally, or all this just hiring people now for job and stuff, they used to consider what, efficiency. So now let's say we want to on an LED. So what we will do, let me comment this one. I don't want to delete it. Let me comment it. Just to comment something is just what, to make the what, make the Arduino or the IDE not to what, consider that line as a code. It will consider it as a text. It will not affect your code. So, oh my God, I've done some of the IT here. I think I will start a new one. So what we did was what, you need to specify what, let's say let me check. I don't need to disconnect my cycle. Let me find a LED that is already connected. Okay, let me check its pin. Okay, I have an LED that is connected to, okay, let's use the inbuilt LED, the pin 13, so that we should not waste much time. So you need to define your pin, right? Define your pin, which is, let's call it LED pin what, 13. We need library. No, we don't need library in order to use the millis function. We don't need to use library. We need to do some initialization, which is what, we need to specify our pin, which is the LED pin, as what, as output, so that the Arduino will know, okay, this pin will be used as output. But initially, let our output be what, low. So this one, we are telling the Arduino, okay, we don't know the state of the LED. Maybe it is currently on, or maybe later on it will be on, and we will need it off or something. So the reason of this initialization, after uploading your code, it will initially turn off. It's very important. It's very important. Always make sure to turn off the LED you will be using, the pin you will be using, to be low before what, start executing your line of code. So the first thing to do is, mind you, once you do pin mode and write input, what the Arduino will be doing is that it will be considering that um, pin as what, out input. Some people used to advise us to use a resistor in order to protect that pin from getting damaged from some certain input, because the input you will be inputting might be certain dangerous, or kind of a signal you are not sure about. But I had some reference that say what, that input function, this input function, if I call this input function, do you know what it used to do? There is an inbuilt resistor for each pin, for this digital input output pin, that once you call that input, that the Arduino automatically, with the help of this input function, it will what, enable that input sorry, don't mind me, that input resistor to protect your pin. So please no need to use external resistors in order to slow down your work or something. So you will see so many references from so many people. So just be sure which one to choose. So the next thing to do, like we can just do digital right. Please, sorry, let me see how many people are online. Okay, just happen. Please, if you have something to do, see, we have already reached an hour, and I think our official time, though I didn't specify the time will be ended, but I think an hour for online class is enough. So please, it's okay for you to go, but I don't know, maybe if Mr. Samuel, if you have some information to pass for them, maybe so that they can, if we have some people that want to go, they can leave so that later on we'll send the link for them to watch the video or something. Since we have already taken your attendance for you guys that have already came, so I think, please, so let me keep on. Please, if you have anything, Mr. Samuel, if you have anything to say, just stop me, or if someone needs to leave, please. It's not that I'm pushing you away, it's that I don't know, maybe if I'm holding you too long or something. So we know we can do what digital right, call our pin, which is what is our pin, which is the LED pin, as what, as high, then what, then we write a delay function. Okay, my this thing, let me see at my secondary screen. It's so small. Let me use my magnifier. Try zooming the code, it's not zooming. Where is it? Whatever then. Maybe like this. Yeah, wow. Then you can do what? You can do your delay. What? Let's say you want to delay it for 500. Then what? Post it. Then what? Set it to high. We like copy and paste, right? It really leads us towards error and mistakes and stuff. But we still can't avoid using it. So your next delay can be at the top or at the bottom, it doesn't matter, because it is a loop, right? Even if you write it at the bottom, the next, you see here, there is no another code to be executed. It will come upward, then execute the first code, which is our delay. You can put it downward. But in some applications, depending on your code, you cannot use it upward. So just, okay, before uploading, I think everything is right. Let's upload it. This magnifier, it's okay, we have to save it. This magnifier is kind of difficult to manage. I don't know, maybe if you can hear a beep sound, beep 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 beep. That beep sound is just that I connected a buzzer to what, to my which pin again, to my pin 13, and pin 13 used to light up what, whenever maybe your Arduino board is ready to be operated. So okay, as it upload, just upload and beep. I'm not seeing any sign of pin 13 blinking right now. And it is an inbuilt LED. It's supposed to blink because we didn't do any circuit rather than saying what. Okay, just blinked and okay, now it blinked. So this is really, let me upload it again. It just turned on and remains on, and the delay is alright instead of our LED is 13 digital low, because we need to see the output like before doing the millis function, and this thing doesn't want to work, and I don't want to do some waste of time doing stuff, checking what's wrong. This thing, it seems like this thing tonight doesn't want to cooperate. To avoid all this wasting of time, that is the reason why I've already do all the circuits before even the class, and this everything was working. It is now that this thing all just wants to waste our time. delay, right, high, low. What's there? Oh, there's a function. Can someone remind me? There's a function used to call the built-in LED. Is it built underscore in or something like that? Instead, there's a function that used to be you can call the built-in LED directly without assigning it to pin 13 or something. Please, can someone help us? What do you call it? My cell phones like that. Building LED sticker. I don't want to waste too much time just on this small thing. Okay, you know what? Let's just not waste too much time on this thing. Let's just get on. So the next thing we have to do is that once we call this our, where is my sketch? I've opened too many tabs, like it's so supposed to be up. Okay, see it here. So if you call this our pin 13, it will be on and off, right? What if we want to avoid this delay and use our milli function? Just to do that, what initially here you will what specify our I will declare our what variable, which is what the start time. It doesn't matter what you name it. Start time. Let me all use small letters, not to be. We have our start time. Your start time initially used to be 0. It depends on you. I want my system to operate what immediately without any waste of time. Because if you want to delay maybe after 1 second when the system solves, then that specific level of code that you want it to be executing using that milli function, then you can specify it. Not it is a milliseconds. That means that what if you say 1000, your line of code will not be executed. It's not that the system will wait for. The system will keep on executing its void loop function until the Arduino reaches 1 second after being on. Then this then line of code will start operating. So we are going to use those 0. That means immediately. Then we can declare a variable. I say I will use small letter. I keep writing capital letter. So we are going to use what the current time to store our number of seconds. But it used to get long. You can use what? You can use unsigned. Okay, sorry, it's small, right? You can use unsigned long or long alone. It can do the task for you because that means if you want to execute it for a long period of time, because the value will come and reach what the threshold of your int integer, your int variable, because you know we all have the maximum of data our variable can handle, right? Depending on the declaration. If I write long, it can contain much more data than just int. Because for int, I think it can contain from 3000, 32,000 to what minus 32,000. I can't even remember the unit. Is it bits or something? I don't know. So that is the amount of data it can handle. But for unsigned long, it can contain much more. So since it's just for a short period of time, we can leave it that way. So after our current time, what else do we need? We need our interval. Our interval, we need it to be operating after what is our delay? 500. So let's leave our interval also to be what? 500 milliseconds. That our put on our semicolon. That I think we are done with the initialization. Then the next thing for you to do is what? Just calm down a bit. Get in where you want to use your millisecond function. Then for each loop of this void loop, you need to be storing what the time of the microcontroller. That is the time it has spent on. So that means what the current time that time that the microcontroller is operating, assign it to what? Call your milli function and leave it that way. So that is it. And the next thing you can do is what? Do your condition. Write your condition here. Let me cut this thing. Let me cut it. Write your condition. Then the line of code you want to execute at that particular time, then paste it what? Within that curly brackets. Let me come down. You need to do tab, right? For it to align to be in index towards to it. So do your condition. What is the condition that I specify? I said its condition is what? Okay, my cursor is blocking. Current minus what? Okay, it's current time. Is it current time? I used to forget names of variable when I'm coding. It used to be very kind of not fun. Minus what? Minus the start time. Okay, am I writing my variables right? Minus start time. Yeah, it's start time. Then what? Is it greater than or equals to what? That particular interval, which is our interval. Oh, is it interval? I wrote here interval. I'm so sorry for the stuff. I'm not good at cramming. I used to do something now I forget. So that is why I don't used to cram functions, codes, and stuff, because you know there are codes that you need to cram them. It's just that once I want to make use of them, I just Google it and make use of it. I don't care as long as I provide the solution that I'm asked to provide. It doesn't matter. Get your cash, get your credit, get your everything. It doesn't. That's the point, not the cramming or stuff. So the next thing to do is what? Okay, your line of code is already there. Then get rid of what? This delay function. I'm really sorry for this thing messing up, and I don't want to take too much of your time. If not, we could have done this practically. We will see how this thing is very effective to our system. So the next thing to do is now, once this, what is our start time? Our start time is 0. What is our, what do you call it? Oh, come on. What is our current time? The time the system has been start operating. So it is going to be subtracted from what? That start time, which is 0. That start time is not going to affect that that start time is not going to affect the current time, because it is what? 0. 1 minus 0 is 0. 2 minus 0, 2 minus 0 is what? Is 2. It doesn't change anything. And that 2 or 1 is greater or equals to what? That interval. So that means that what? It is greater than what? Or equals to that interval. So it will wait until what? Until this condition has been what? Fulfilled. So okay, this condition is true. Okay, let us execute this line of code. So what is the line of code? We are going to digital write our words LED to be high. Okay, once we made this LED to be high, okay, what we used to do is what? Put a delay function. For this time around, what? We don't need to what? This, we don't need this. Now that means that what? For every 500 millisecond, this LED will be what? Will be turned on. That means what? It will be turned on for this interval. So you can do the same thing if you want to what? Turn it off. Because if you leave this your digital write low, it will instantly turn it off and low. At what frequency? At the frequency of the microcontroller, which is around 20 megahertz or 16 megahertz, which your eye cannot even notice that what the LED has been high, because as long as it is high, it will be low. So we need to specify the delay, and we don't want to use delay function. So we can do the same thing for what? For your low. So if you like, you can make the code more efficient, but if you like, you can do something like this. But mind you, for each device you want to control, or for each control, you see, this is another disadvantage of what? This is another disadvantage of the milli function. For each function you want to perform, or for each device you want to control, you need to specify that device variable. Because let's say now start time 0, current time interval. So now if you want to control a servo motor, we need to specify int start time start time, then what? Okay, then what? Servo. Because we know this is for what? This is for servo. You see the another disadvantage. So you are going to have bunch of variables listed above, because for each device there will be what? 3 variables, which is efficient, but it doesn't matter if your code what get to execute what much efficient. So after what do you call it? If you're writing digital right now, want to give me a heading. You see, what do you think will happen now? Once the system starts, it will what? It will store this millisecond here. And what do you think will happen? This digital write what? Digital write low. Your system, your LED will be what? Will be at low state. Until what? Until this interval has been fulfilled. What is our interval? Our interval is we will keep on counting as long as this current time is increasing. Okay, our current time is not 200 millisecond minus start time. What is our start time? It is 0. Okay, we'll keep on doing it until what? Until we reach this interval, which is 500. You see, your digital write will be what? Which will be low for what? For that interval time. Until that interval time has been achieved, then what? Then your line of code will be executed. It will be executed, which is what? High. And after that high, what do you think will happen? The system will what? Okay, let me wait. Because after this line of code, let's say I didn't write this line of code. After this line of code, what do you think will happen? The code will come all over again, right? It will check in. Okay, there's another distance. If you remember our it's not here. Remember this place. We say we need what? A declaration for what? Or as an assignment for what? The start to be what? To be our correct time, which is what we are updating our start. If do you know? Do you think what will happen if we didn't update this start time? The interval will keep on what? Getting large, because our start time in the first place it was 0. So we will only wait for what? We will only wait for what? 500. At the next step, it is still 0, which the condition is already true. So nothing will happen to our system. I'm talking kind of abstract. This magnifier is kind of confusing. Oh my god. Yeah. Oh my god, this is around 1 hour 30 minutes. I'm so sorry. And I spent much time and we didn't even get to do the practical. We're supposed to spend this time while we have done the practical. And I have spent this time without doing the practical, which is not efficient. But I don't care as long as some of you get something new from what I'm teaching. That's the point, right? It's not about covering the syllable or something. It's about you getting what, how the thing works, the concept, learn something from it, apply it somewhere, or teach someone. That is the point of the workshop, not covering the syllables. Okay, our start time, right, will be equals to what? Will be equals to our current time, which we are what? We are now updating this start time to take the time of what this current time, which is what? Which is what? Our what? 500 millisecond. So let me write my semicolon. I used to forget this a lot, this semicolons. I'm just surprised that in this session I didn't forget this semicolon much. So because we have Python users. The next thing to do is what? You can do for that of what? Low function. This curly bracket is for the if both. Oh, I thought I copied. If you understand the code, understand the concept, you can optimize the code in uh, much more efficient way that I'm doing, because I'm just adding the work. I'm adding too much lines of code. It's not efficient. Yeah, this code is not efficient. You can do better than this. Okay, now we need to what specify. Let me just write it before even specifying above. Let's say for the low, and for the what, for the low, which is not efficient. We are doing it for high and we are also doing it for low. So that means that what, once your system is on for what 500 seconds, that means at what second? Okay, this one is high. This one should be low. That means that what, once this line of code is on, it should be what? It should be what? Delayed for that particular amount of interval, which is, this should be low. This also should be low. Yeah. So you should be what? You should be wait for. That means we are doing duty cycle here, right? Or it's not kind of duty cycle, but let's also consider it as duty cycle. The amount of time that the LED will be on, we set it to be what, 500 millisecond. So we want to turn it off and on and off. That means that what, for a one complete cycle we get what, we get 1 second. So that means that what, after this one is on, it should what, it should remain on for what, until this interval is satisfied. It should remain on until this interval is satisfied, which is what, our interval of low. Then we'll set it to what, to 1000. That means that here will be on and it will stay for what, initially our system was low, right? When the code start executing, it was low. So the system will be what, will remain low for this interval, which is 500. It will turn on. Then now this line of code should make it what should make it what, below for what, for this interval of time, which is what, 1 second. That means that we have complete our duty cycle. Then it should be what, it should be low. LED low. I think, is there anything else? Start time is equals to what, low time. Then you can what, since we are not doing this thing practically, then you can go up and what, and update this your low, because once you compile it, it will tell you that what, they have not been declared, because I didn't declare them. So you can go up and what, and declare your variables, because we are not going to run it. Oh my god, what did I do? This magnifier. You see, your variables are not declared, so you can go up and declare them. You see, I believe you get the concept, because I'm really disappointed for this my setup here that I brought with me, and it's not working. So, and I don't want to waste too much time, which we have already did. We will have what, made use of all these components that I brought along with me to what, to see everything practically. Let me stop sharing this. Okay, I made use of an tangent brother for me to be able to just focus on my, okay, my camera is not, let me share my, let me turn off my camera, then share my screen. That's my secondary screen. Share screen automatically. Yeah, start now. I believe majority are using their phone, right? So this one, my secondary device is just a phone. So let me just enter my camera. So you can see all the distance. So I have some few devices, and okay, I have recommendations for you. I think for the class now we are done. You can go and do. Let me increase the ratio so that you can see what's wider screen. The ratio, yeah, wider screen, full screen. So you see it. So I have recommendations where the recommendations are what some places, website that you can get some of materials, or you can get a solution that you have been thinking. You know, one thing with embedded system, you might once come up with something that is giving you headache, and you will be thinking that where can I get solution. You'll be searching it on YouTube, and you can easily get that solution. So that place, I believe you can get the solution. It's just that you have to take your time searching. The first thing I will recommend it to you is that you see the servo motor, right? Servo motor, we used to use servo motor for some applications. Once you are going to use your servo motor, this one is just a small servo motor for practicals and prototyping small things. Okay, so what if you want to use a one that is bigger than this, or you want to use 2 to 3 servo motors? You know, motor used to consume what higher power than all these LED and stuff. So the purpose is that what once you want to use 2 to 3 servo motors, which are much, they are going to drain. There's no time I will have shown you that once earlier when I powered this servo motor and one LED was on, that LED used to be dim, because what, just like your house now, once you on your gen and someone owns iron, you'll see if it is not a high watt gen, you will see that the voltage reduce or the power reduce, the wattage reduce, right? So the same thing with this. Once you on your servo motor, once another LED is on, you will see that what another LED will kind of be dim and stuff. So do to avoid what should you do to avoid that? So you can use external power supplies. When I say external power supplies, I doesn't mean that to go and buy transformer or something. What I mean by this is this external power supply. This one is also an external power supply. We call it the breadboard power supply. I know it will be difficult for you to get here. Maybe you have to search online, because I also get mine online. Though this one has spoiled. I'm getting so much difficulties in using some of my power consuming devices like the servo motor and stuff, because I burned my this device. So you can search for the schematic diagram for it online. It's very simple diagram. You just need a voltage regulator and stuff, so that what once you power it through this power jack, which is 9 voltage, it will go through the regulator and regulate it to 5 volt, and you see what you have pins. It's laggy, right? You can see it, right? We have pins below it, which you can directly mount them on what on the breadboard. They used to go like this directly to the breadboard, going to your what power rails. I'm sorry, this thing it's just that I'm not recording. You see it, right? So it can go directly to your what power rails, powering, making you what make use of power from this device. But mind you, when using external power supply, you have to make sure that what the ground of that power supply is what is being connected to the ground of your what Arduino, the main system, because what the circuit will be complete and they can exchange data. Because if you didn't connect their ground, it's just that one operator is operating independent with another one, and they can't see each other. Okay, so you have to do that. The next thing I recommend you to use is what. Okay, the regulator is like something like this. It's just a three leg something like a transistor that you can use, and it's not focusing, that you can use and not and regulate your voltage. This one is not a regulator, but I just use it to make it to show you how it looks. This is a MOSFET 3205. So you can make use of what this power jack to what to connect this kind of battery. You can buy this one online also, but I know online now is getting hard. So you can get this battery, the power bank battery, connect them directly to what to your power jack, which is this your power jack. Then what? The output of the power jack should go to what? To the input of what? To your this device, the one I finished showing, the breadboard power supply. So if not, what you can use just direct ways. You can cut the head of the power jack and connect it direct to your breadboard. That made a circuit that will what? That will regulate that 6 volt, or because you connect them in series. Each cell is 4 volt. When it is fully charged, two cells will be what? 8 voltage. Then it will what? It will be regulate. It will be regulated to 5 voltage for your use. So these are the major recommendations that I have for you in using external devices, motors that consume power, because sometimes when you use them, they used to what? If you don't use them, they used to what? Affect the performance of your Arduino, because they are consuming a lot of power from the Arduino, and they can, though the Arduino has been designed to be so much protective, so if not, it can burn your Arduino because it is consuming the power it cannot handle. To make it fast, to round it or maybe in 5 minutes or stop, let me pause this my share screen here, my phone. Let me show you the recommendations finally, and then I just stop sharing here. Okay. I don't know why my phone is too hot at this cold weather. Sorry, I've been talking without seeing, without noticing whether someone has raised his hand or not. Please, is there any questions so far before we round up? Is there any question before we round up? Before I start sharing. Okay, can you see my screen? Let me see my secondary device here. Okay, so the next thing we do is the recommendations. Just heading straight to YouTube. It's obvious, right? YouTube, YouTube, YouTube. We need YouTubers. Before I used to have my mentors from YouTube, but you need to find maybe physical mentor or stuff. So once you get into your YouTube, okay, let me get. I have them in my head, but it's there in my slide. Let me just show you. These are the recommendations. I know some of you here know them, more especially Mr. Sao. I know you know these people. They are very rich, very good. They provide everything we need for us. They provide anything we need in embedded system. Any explanation for every system, each field they have covered each field. It is not possible for you to search something in entire embedded system track a system, or you are trying, or an idea that you didn't find it among these three, and they are the best. I don't know, to me they are the best. They have awards for million subscribers in YouTube and stuff. So next thing, the first one is the word electronics. I don't know, maybe electronics. I don't. Oh my god, I missed B. What? It's automatically space. I'm not the one giving that space. Okay, see electronics. You have 541K subscriber. So I don't. You see, this is his channel. You can read about him. He's into electronics, 3D printing stuff. You can join his channel. You can subscribe to his channel. His accent is kind of, it's good though, but I believe you can understand his accent. But his accent, yeah, is understandable. You can see some of his projects and stuff. So he used to explain things in detail that definitely you will understand. He used to provide evidence using oscilloscope and stuff. And so many these big companies used to sponsor his video, like the words, the JPLCB and stuff. They used to sponsor his video. You can see so many attractive projects that can inspire you. You can find inspiration among his channel. You can go through his channel. Let's not waste too much time. Next one we have is the drone bot workshop. The reason why I'm recommending these people to you, I have years and years of experience from all these people that I don't need anyone else. Like they are the ones I just need. Like if you can see him, he's a little bit old. He's old, but yet he has what do you call, the passion for embedded system. Yeah, he used to do research and stuff on a particular topic before even start to present that topic for you. His video used to be longer than any of the other YouTubers that I've shown you, that I'm about to show, and the one that I've showed, the Electrono. He used to spend hour. You can see his videos, right? 1 hour 30 minutes, 1 hour 57 minutes. He used to spend a lot of time so that he doesn't accept to himself that to proceed until what, until the ones that he's tutoring their words, they understand what he meant. So that is the advantage of him. He used to explain something in so much detail. He have so many, what do you call this collection of videos? Is it library or a series of videos? You used to have series of videos because you don't want to be video to be much longer. You can see everything is in details, even the circuit diagram. His accent is very nice and great, and the audio, his audio device, everything. You can see you do IoT a lot, because IoT and machine learning, they are what the new technology of what embedded system. So just hang in there, finish embedded system, then you can start doing machine learning and what IoT. That is when you will start developing high efficient project that what will be attractive to the world and providing what so many solutions that what people think that those solutions cannot be provided by what machines, embedded systems. You know, embedded systems have so many. Let me check. Okay, how to mechatronics. I believe there are some mechatronics students here, right? So the guy is also a member of mechatronics, but not of ATBU. It's just that he's into mechatronics. Why is the that auto mechatronics is the one that I consider to be what mechatronics is the one that I consider to be, shall I say, the best. I just like the guy kind of, though his project and explanation is to be much on what mechanical, electromechanical something. So that because what is into mechatronics. So if you need any project that consider 3D printing, how to build a 3D printer, or how to do something that is a relationship with what, that is a related to what mechanical something, this man is what is the best, I think. You can see how he built in so many robots. He used to explain things in details. How he used to do. You see, a writing machine using what, using some servo motors and stepper motor. You see how the system write very neat. So you see, you can get into there. It depends on your interest. He built a remote, RF radio transmitter remote. You see how he designed his PCB. How this one he did everything from scratch. He used to do everything. You see, even web development. Sometimes he used to teach web develop. Did I say web development? Sometimes used to teach what, um mobile development. You see, he used mobile development, develop this app. What is the purpose of this app? Is to what, controlling a certain arm that he has created. That's right. You see how to make a it. You see, he just made use of what the robot arm can now be controlled by. I can see that my share screen is lying from my secondary device. Let me know so you can go and see it yourself. So he's the last one that I'm about to recommend for you. We have so many others, but these three. If you need something that deals with embedded system and kind of robotics, you can go to this mechatronics. If you want something that is purely embedded system, you can go to electronics. If you need something that is kind of latest technology, a latest trend, you can go to that drone bot workshop, because any new technology that has been reduced about embedded system, it used to make sure you be the first one or among the first persons to display that technology and explain how does that technology works. If you want to do IoT also, go to that drone bot workshop. It's very good. The time I started learning IoT, really inspired me, like when seeing the way you used to do things and stuff. Please, is there any question? Okay, if there's no any question, I'm so sorry I've taken too much of your time, but I keep on repeating. As long as we have learned something, it doesn't matter, right? Because we sometimes even spend our time on something on something else. But see now, I think I will also be glad if you have learned something from this session and stuff. So, Mr. Samuel, I would like you to say 2 to 3 things. Oh my God, he just went out. Maybe it's this thing.
Hello, can you hear me? I've been trying to talk. Can you hear me?
Yes, now we can hear you. Before you went
Yes.
to.
I've been trying to talk since that's just been misbehaving.
Oh, oh, I'm so sorry. Since that time we can't hear you. It's now that we can hear you.
Okay. So yes, I really enjoyed this session. I was around all through. I'm sure some of these guys too. They they have picked one or two things. One good thing that if they go back to your maybe to do some extra reading from this tutorial now, if they say anything, you can relate to what the person is saying since you have been taught in class already. I even me personally gain a lot of new things. So as you can see, the meeting is recorded. Probably some of us might still need to go back to recording, or if not, people that are not able to join, they can still check the recording. I'll make the link available on the group for us, and we can listen to the recording. So I think it's good if you can even probably if it's just once in a week, maybe every Sundays we can have this kind of session. I don't know, Mr. Makama, will you be available like every Sunday? We talk about some software stuff. What's there to even probably
Yeah,
we should even open it to since some of my engineering guys interested, not people that are in the boot camp, normal departmental guys, just maybe open it up. Everybody, people can
yeah, we
join.
can make it open there for everyone since it's just a bonus session.
Yes. So
Yeah.
that's what
Our topic for next Sunday should be on H bridge. You can start doing some research on it. Maybe H bridge. If I haven't come up with another topic, it should be on H bridge.
okay. So just make it every Sunday now we meet, and then probably give some
Okay.
assignment so that people can start working on during the break. I'll be during the week, and by Sunday we
Yeah.
all come talk about some topics in the embedded world.
Yeah.
But
Yeah.
really, the demo was okay to do with the way we are showing your camera. It was good.
Okay. You were able to see it.
Yes, especially that time you are using your secondary device and then you are sharing the screen from there. It was very
Okay,
clear.
it's better that way, but
Yes, very clear.
okay. I think maybe next time we will prepare for it
I'm
because this is the first time I've used secondary device to display something. I thought it will be too poor.
that time we were sharing the screen. It was very clear.
Okay. Please, does anyone have something to say? Because just being so silent, like it's not interactive. Since we are not that much, at least everyone should say something now, starting by you, Embrace. Yeah, come on, you can speak up. We can't hear you.
Still, no. Are you hearing me now?
Yes, but
I want to ask that all these things you are doing online, can you do it physical class? Just
sorry,
I
sorry,
said
come again.
all the things you taught us online now. Can we have like
Okay.
physical class so we see everything? Not like everything we see.
Well, actually, we have our syllabus for main class, so this one will be kind of interrupting with our main class. But I don't know, maybe if those that have interest, we can fix some time, maybe after each our physical class and talk brief in the physical class. I don't know. Or Mr. Samuel, do you think we can a little bit do the demo in our physical classes so that majority will be able to.
Yes. We can do that during physical classes.
Okay.
You know that there are a lot of restrictions in school now. They're not really allowing students to enter school again. So I'm not sure if we really gather inside school and be doing
Okay.
something. Probably some people are still around that can come for the classes, but because of the restrictions, we just hold till January.
Okay. Yeah.
Well, thank you.
Thank you, Mr. Ambrose. The next thing on my list is Musami. See someone there have my name. Musami, come on, speak up.
But I don't really have anything much to say, just that the class is very informative and I learned a lot.
Wow, thank you, Musami. I'm glad that all of you here maybe learned something. I'm really glad about it. Okay, my name's Sek. I'm also Abdulmalik. Come on, Ridwan.
Probably it's not even around.
Maybe he went away. Maybe he's away.
Yes.
Okay, he's still there. He just don't want to talk, maybe. All right, I think this session is almost 2 hours. All right. All right, I think our next class will be better than this because I was not emphasizing on the practical aspect. I was emphasizing on the abstract and coding and stuff. But since we have found a way to kind of see, to be able to show you to do the demo for you guys, I think our next class should be better than this.
Yes.
Yes. So I think if there is anything else, then if there is not, I think we are done with the session.
Yes, you can start.